Okay. So, so that is a finish to the fun that is Fibonacci. Next. Okay. New topic. Counting. Yes, 1, 2, 3, but not that kind of counting. So, suppose Jason wakes up and gets dressed. He has 3 different shirts to wear and 2 different pants. How many ways can he get dressed? Or in other words, how many outfits? Okay. Oh, that's so easy. How'd you know that? 3 times 2. Okay. So you're exactly right. So since you all know that it's 3 times 2 equals 6, I can sort of speed through some of the preliminaries. I'm not going to skip them entirely because they give us ways to deal with harder problems. Alright. So if you didn't know the answer was 6, how could you jot stuff down to help you figure this out? Okay. Yes, you can draw a tree. Yes, you can draw the combinations. And what else? Okay, so you can do all these things. So the first thing I'm going to say is you can draw a diagram of what all the possibilities are. So a diagram where you show all the pairs. Okay. Another way to do this is to write out a list of all the possibilities. Now, of course, the tricky part with a list is you have to make sure that you got everything. So a bunch of people shouted out 6. So, but a bunch of people did not. So does this make sense, or is this going too fast? Do you have a question? Okay. So the next, someone also shouted this possibility out is you can draw a tree. So how do you draw a tree? Okay. Pretty much. So how many different flavors does the bark have? Okay, so if the bark is pants, it's got 2 flavors. And then how many flavors do the leaves have? 3. Exactly. And what you have to do is, and again, you can do this in either order. You can either talk about the pants and the shirts, or the shirts and the pants. So say you start with the pants, you split to 2 different possibilities off the pants. Now, once you decide that you're going to wear, say, red pants, then from there on out you have 3 possibilities for sure. And then, so the tree branches again in 3 directions. But then you also have the same thing on the bottom. So for the other type of pants, you also have, again, 3 possibilities for the shirt. And doing it this way allows you to actually see all the 6 possibilities. So part of this 3 of the possibilities have already been enumerated. But then also notice that, for example, this 4th possibility would be orange pants and a blue shirt. For example. All you do is just follow the tree from the beginning. Does that make sense? Okay. And yes, as everybody said, you can always just do 3 times 2 equals 6. Okay. Now, can we always do this? Well, in this case, yes. Alright. And I want to give you another picture to show why the 3 times 2 works. You can see that 3 times 2 works if you make a chart. And here's the chart. So how can you use this chart to explain why doing 3 times 2 works? Okay, tell me what you see.
You can pair some with a shirt and with a different color shirt.
Uh-huh. And what does that have to do with this chart? Sorry? Uh-huh. Okay. So I'm sure it's so obvious that you can't even say it. Yeah. But here's the point, is that what we did is we created a rectangle that has one dimension of 3 and another dimension of 2. Well, the area, if you like, is going to be 3 times 2, which is 6. But what does that have to do with pairing shirts with pants? Well, every box represents one outfit. And that's the whole point. Now, this is easy to see when you have shirts and pants, just 2 things. What if you had 3 things? Well, if you had 3 things, you'd have to draw a length, width, and a height. That's kind of hard to do on paper. So we're probably not going to make a chart for that, but the same principle still applies. Yes. And that brings us to our first basic counting technique. If you want to do a couple of different things, in this case, choose pants, choose shirt, but this could apply to anything similar. If there are A ways to do the first thing, and B ways to do the second, and C ways to do the third, etc., then the total number of possibilities is A times B times C, etc., as far as it goes. Okay. So is that sufficiently straightforward? Okay. Next. So now I shouldn't say next. I should say this next one requires a bit of cleverness. Suppose a family has 3 kids. Every kid is, of course, a boy or a girl. How many possibilities are there for, I should say, how the kids came out? In other words, not in amount, but the order that they are born in. Okay, why 6? Okay. But is that how things happen? Okay. So think about the outfit previous example. What's the first thing that happens? First you have to choose a, I don't know, say shirt. There are 3 ways to do that. Next, what happens thereafter? You got to choose pants. And how many ways are there to do that? There's 2. Okay. So now apply that thinking to this family. All right. Okay, now why do you say 9?
So many of those three songs we have to it could be like a boy, girl, boy, 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 girl, girl, boy, girl, boy, boy, girl, boy, like that.
Yes. Okay. So another way to approach this problem. So we're going to take a time out from what I was just asking you, and we're going to approach this problem using the method that Terrell said. And what method is this, by the way? You're ahead of me, yes. But what we're doing is, if you're going to say, well, it could be boy, boy, girl, boy, da 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 da, and you're going to write that out, what is that called? When you write stuff down, what is that called? Making a list. Yeah. Okay, so we're going to make a list. Okay. So what are the possibilities? Okay, boy, boy, boy. What else? Okay. So let's see if we can get them all. Boy, 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 and what else? Girl, girl, girl. What else? Girl, 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 boy. What else? Girl, boy, girl. Girl, boy, boy. What else? Girl, girl, boy. Already have it.
Oh, we can start with boys now.
boy, girl, boy, 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 girl, boy, girl, boy. No, we already have that. Oh, boy, girl, girl.
What about boy, boy, boy? Because they didn't.
It's already there in the first one.
Oh, really?
Someone said it. Okay. So, are there any other possibilities? Okay, so we have 8 possibilities. Is this all there is? Okay, so yeah, this is it. But as you can see, if you don't have a principle to organize yourself when you make a list, then there's no way to know if your list is complete. So this is kind of a problem. So what we need is a way to organize this list, and what it actually comes down to is something Terrell said 30 seconds ago. What does this remind you of, Terrell? Yeah, this is just like making a truth table. Because boy versus girl is very similar to true and false. Exactly. Now, how many? So in this case, we had 3 things that we had to fill in. Well, do you remember from talking about truth tables, when you have 3 things that you need to decide, how many possibilities, or think about in truth tables, how many lines in the truth table were there going to be? How'd you get 8? Do you remember where the 8 came from? Or do you just remember that it's 8?
True, false, false, false. True, true, false, 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 false. Because it's like 4.
Oh, okay.
2 and then 1. It's like 4, then 2, and then maybe 1.
Uh-huh. Exactly. Okay. So 8 becomes 4, then 2, then 1, if you think about how the trues and falses get arranged in the table. So here we actually have things arranged in order, more in order, just as we did with the truth table. Now the question is, okay, beat me to it. Why is it 8? Matt, just arithmetically speaking. Well, maybe we can see a little better if we make a tree. So if we start from the beginning, how many possibilities are there for the first? What's the first thing we need to make a possibility for? Okay. So how many forks should I draw? 2. And what goes on each fork? What goes on the top fork? Sorry? Boy. And on the bottom? Girl. Okay. Now on the boy, how does that split? How many branches do I draw off of the boy? And what are they? Sorry? What could happen next? Okay, but how many branches do I draw? Okay, what's the first branch? Are you telling what's the second branch? And what's the third branch? But we already have boy. There's 2 branches. Remember what the tree does. You only do one thing at a time. Now, off the top boy, how many branches do we draw? And what goes on each branch? Boy, girl. Now next, we're at the here. How many branches come off of that? 2, which are boy and girl. Now we'll go to the bottom half of the tree. How many branches come off girl? So what are the possibilities as enumerated by the tree? What's the top? If you follow the tree on the top, what's the first possibility? What is the top possibility? It's that branch right there. Boy, boy, oops. Boy. What's the next one? Right. Boy, boy, girl. What's the next one? Boy, girl, boy, and then boy, girl, girl. Okay, and then the same thing for the bottom. So does everybody catch this now? Maybe a little refreshed about from remembering how we made truth tables. Okay. So now where does the 8 come from? Yes, but in terms of arithmetic, where does 8 come from? In terms of the total possibilities. How could we get 8 by doing arithmetic? Yes. Because what's the first event? 2, and where does that 2 come from? Boy or girl? And then next times 2, because the next event is the next child, which has 2 possibilities, boy or girl. And then there's the third event, which is the third child, which is either boy or girl. So it's 2 times 2 times 2. So the thing is, when you come into a math problem, particularly a real world one like this, you can't just say, oh, I've got some numbers, let me multiply them together. I'm genuinely teaching you how to count. And by count, again, I don't mean 1, 2, 3, 4, 5. I mean when you have a bunch of different things going on, how many different ways can it happen? Now the trick here is to recognize what are the different events. So the first event is the first child, 2 possibilities. Second event, second child, 2 possibilities. So you wind up with 2 times 2 and times 2. You don't just say, I've got 3 kids, each one could be a boy or a girl, so I do 3 times 2. Because you have not split it up into the events, where each event has 2 different possibilities. In the same way that the very first example we did, we're getting dressed. What are the events? The events are put on a shirt, put on a pair of pants. 3 possibilities, 2 possibilities. Same thing here. It's less clear, but now you should be able to understand how to read a problem and figure it out. Okay. So just as a reminder, you guys tell me. Suppose I get dressed, I can choose from 3 caps, 4 shirts, 2 pants, 6 socks, 2 shoes. How many different outfits are possible? How do you figure it out? Right. Now you could draw it out, but do you want to? No, that would take a while. Right. So the thing is to understand this basic principle, is that you can just do it as multiplication. You can get 288. Okay. Next. State license plates. It used to be the rule for state license plates that, in fact in some states it still is, the plate was 6 characters, 3 letters, followed by 3 numbers. So following that rule, how many possible plates are there? What's the first event? What's the first thing you have to choose? The first thing you have to choose is a letter. So what number would go there? 26. What's the next thing? Does it's why 25? Does it say that you cannot use the same letter? Okay. So the next thing is 26. What's the next thing? Another letter, 26. What's the next thing? 0 through 9. How many digits are there? 10 choices. So what's the, and then, so 10, and then what's the next thing you have to choose? 10, and then 10. And what do you do with those numbers? There you go. Okay. So do you understand this idea of sequencing and going event by event? This is the key. So about a little more than 17 million plates are possible. Now it turns out they actually used to have this rule in New York, but they ran out of plates, so they had to allow more possibilities. Okay.